Fluid is the lifeblood of the equipment. Hydraulic fluid keeps the flight controls working. Oil and other oil-wetted fluids keep our components cooled and operating sufficiently. And without that in our airframes, our aircraft don't fly. It's just that simple. Let's say, for example, we have an issue where we think that we have contamination. Water, for example, in a hydraulic system can completely shut down that hydraulic system and cause a catastrophic failure. That means we lose people and equipment.
Contaminants that could be found are things such as water contamination, fuel dilution, coolant or glycol dilution, sand and dirt contamination getting into the system. If left unchecked, can cause severe damage or catastrophic failure.
Fluid sampling and fluid measurement in laboratories is not convenient, it's not cost effective, and what we need to do is make it cost effective.
The current system that we have at our disposal is to first pull a sample from the field. You package a sample at the field. You ship the sample to a laboratory. The laboratory conducts laboratory analysis. The analysis is then turned around and given back to the field. Now, those steps take time, they take money, and they have a degraded impact on readiness.
One of the difficulties in fluid assessment is that the government has to balance the cost of testing the fluid, the cost of sending it to a laboratory, with the cost of saving equipment or reducing maintenance. And that balancing is difficult to achieve. One of the reasons it's difficult to achieve is that shipping costs and fluid costs and the cost of pulling those samples, those are expensive costs. So if you can't reliably demonstrate that you have saved significant numbers of assets and translate that into real dollars of savings, it's difficult to justify those programs.
The DoD's main goals are meet threats, stay focused, and develop asymmetrical responses to the threats as they present themselves. In order to meet those goals, maintenance of their assets and technology has to be centered around agility, flexibility, and readiness levels. And the approach that is most suited to meeting those goals is condition-based maintenance.
The idea of condition-based maintenance is you don't take any action until action is required. For example, you don't change the oil until the oil is bad. We're extending the life of the equipment. We're changing the oil based on need, actual need versus calendar time, which ultimately ties into condition-based maintenance.
Our whole goal is to keep our planes in the air, and we do that by condition-based maintenance. We know that testing oil in the lab is an expense. It can be very expensive. But if we had a handheld device that we could actually test on the spot, that would reduce all those costs.
So that forms the basis of the 3FAST program. And a research effort was mounted to come up with a technology that was able to address these areas in these particular strategic goals, and to come up with a technology that would solve the most pressing concerns for the military in those areas, which was in the area of lubricant condition.
What we've done is miniaturize current lab instruments, and we've created this handheld portable oil assessment tool so that it weighs approximately 5 pounds. Our warfighters can hold it in one hand, take 1 drop of oil, and be able to get the same results that they would get from the lab.
The instrument is very portable, and that's the best aspect of it all. It can be used out in the field. There's the end user can have it with them. You can have it in their vehicle. You can have it on their aircraft. It's very user friendly, and it's very easy to train on. So anybody in the field can be trained on it in a matter of minutes.
This instrument was developed partly through funding under the Commercial Technologies for Maintenance Activities program. Now, the CTMA program is a special program funded by the Pentagon through the National Center for Manufacturing Sciences to help develop commercial technology specifically for maintenance activities. It's to help give things the extra push so that the military or the Defense Department can use things that already exist, but apply them and adjust them and adapt them so that they meet a military need.
There's a real need to maintain legacy systems because there's a tremendous amount of equipment that has been in the field for a number of years and will continue to stay in the field for at least 15 years. It is very critical that we maintain these systems. That is main emphasis on the CTMA program. We focus on maintaining legacy systems.
I think the potential benefit of fielding a device such as this portable handheld has the number one benefit of improving readiness, improving safety, and reducing cost. Those three elements are the goals, the DoD goals. Without readiness, that soldier, that airman, that Marine, that sailor, those people that we put out there in harm's way are not able to complete their mission, or sometimes they'll have to complete a mission and not in the safest means available.
The only way to get benefits of those assets, out of testing those assets, is to reduce the cost of testing. If the cost of testing right now and sending a sample to a laboratory is $3, then $3 is too high because we're not getting that money back. But if we could reduce that to a quarter or a dime, that changes the whole cost-benefit equation.
A device like this potentially can contribute to safety across the board when used effectively. That's important. As we are giving the user, the person in the field trying to complete a mission, an opportunity to make a decision with a reliable, repeatable, good instrument so that we can carry on the fight.